Hello everyone, welcome back to the session in which we'll be starting with module 2, and in module 2 straightly we'll deal again about Hadoop, introducing Hadoop. So in the module 1, the last topic which we had covered was Hadoop itself, and here we'll be studying much more about Hadoop, like completely about like how we, if you want to understand human physiology, you have to understand the insides of the human, like skeleton, which part is connected to it. It's a thing that this module covers the skeleton part of the Hadoop. Okay, so we'll be starting with the data that treasure trove. We'll be discussing how the data is being generated. So if you talk about big companies, so Google is generating approx 26 petabytes of data every day. Facebook is generating billions of posts, Twitter billions of tweets and all. So all those data is being generated, random data, all the unstructured data, so much of data. Let it be any type of data, structures, so much data. How will you deal with that? So that's why we will be talking about why Hadoop. Hadoop is a very good technology. It's a framework, which supports and solves the problems of all three V's. That is nothing but volume, velocity, and variety. Huge amount of data can be processed with the help of Hadoop technology. That is volume. Variety, all types of data, structured, unstructured, semi-structured, too much, different types. It can be processed by Hadoop. Volume, velocity, and the how fast the data is being processed. So Hadoop will help you cover all the three V's, and this is the key features of the Hadoop. Low cost. So Hadoop is nothing but basically a distributed system, so in which has multiple nodes, individual nodes. So it is what did we covered that topic, right? In which a shared nothing architecture. Then low cost computing power. So see, high computing power. So each node has its own computing power, since it has its own processor, its own memory, its own task operating system. So every node acts as a processor. So if you have more nodes, more computation power. That's what it says. Scalability. Vast number of data can be varied. If you just need extra processor or extra node, it can simply be added. Horizontal scaling, right? So that's what extra node. Storage flexibility, in the sense it allows you to deal with different types of data whenever it's required. It will be like, so you don't have to pre-process the data like RDBMS, in which you have to first process the data, then take it as input. In this, it's not required. Whenever you want, you can store the data, and if you want to process it, then later you can take and process it. You don't have to process and then store. You can store it and then process. Inheritance data protection is about replication, fault tolerance, etc. like that. So it has a replication factor, right? So data is always protected. Why not RDBMS? So RDBMS is not suitable for large files. So if you have large number of files, I'm not talking about GB or TB, I'm talking about petabytes, even more, TB and all. TB also, but like 100 TB or many number of petabytes, zettabyte and all. So it's not suitable for that. Not good for advanced analytics like machine learning. It doesn't support much good with that. Cost scale exponentially. So as the size increases, as the scalability increases, GB to TB to PD, the cost literally skyrockets a lot. Then we have RDBMS versus Hadoop. First we said why do we need Hadoop and why don't we need RDBMS. Now we'll compare both of them. How we do the system. So this has relational data model system, and Hadoop has a node architecture. Node to node data. It's only structured. It supports only structured, but it supports all three: structured, semi-structured, and unstructured. Processing. So it does batch processing. So online OLTP, that is online transaction platform. While it comes to Hadoop, big data processing and analytics. Processor, RDBMS requires high-end, high-quality processors, which is very expensive. But Hadoop has individual node, and each node requires one processor, one network card. That's it. So like that, you can continue with that Hadoop. Cost per TB. So for RDBMS per TB, it costs $10,000 to $40,000. But for Hadoop, it's just $4,000 for 1 TB. Distributed computing challenge. So there are two challenges here: hardware failure and how to process gigabytes of data. So hardware failure every once a year. Okay, so every 3 years, it's very common for one hard disk to fail, hard disk to crash or fail. So now if the hard disk crashes or fails, then all the data stored in that hard disk will go, right? So that's the problem. So if one hard disk failed, thousands of disks are failed. So that's why Hadoop introduced this replication factor. If you keep the replication factor 2, in the sense, if one copy fails, the other is there. But in Hadoop, you have the common default replication factor for 3. So you don't have to worry. For example, if you're working on a project and the major updates you're sharing to all the 3 members, not just one member. If you share the major details to one member, and if he is on leave, then the other 2 cannot work on anything. It's not like that. But Hadoop, what it does, shares all the major details to 3 of them, such that if one is on leave, the other knows what is happening, and they'll be updating and doing that work. It's a real world example just for understanding. How to process gigabytes of data. So see, mostly what happens, large amount of data, how will you take it to the code? Code is nothing but the software, understand. We read about it in module 1, right, where we talk about paradigm shift from data to code. We move code to data. Code is nothing but software, understand, like that. Instead of taking all the data towards the software and then process it, why not we just bring the software towards the data? That's the main thing. So here what it happens, instead of moving the anonymous data to the code, we just bring a MapReduce where it processes the data and generates the key value file. So it's very good for processing the data. History of Hadoop. So Hadoop has evolved since 2002, and the main guy behind him is dough cutting. So this guy, he was working on a project called Nuts that was basically from Yahoo. Okay, so Yahoo actually used this thing with the help of Google Cloud Framework, as GCF. So from that, Google did not actually adopt it, but Yahoo actually took the advantage of it. And from that, what this dough cutting did, and he in depth saw that concept, and then he introduced Hadoop. And the naming of Hadoop, how did the word Hadoop was named to this, is nothing but dough cutting skid. This guy's kid actually was playing with a stuffed toy animal, or nothing but elephant toy, okay, stuffed toy. It was yellow color, and the baby named its stuffed toy as Hadoop, and that's why this guy used that name, thinking that it has no meaning and it's not used anywhere. That's why not take it, and he just named like that. Very silly, right? Anyways, Hadoop overview. So there are 2 things which you have to remember here: massive data storage and faster data processing. So HDFS, we have HBase, we have database and file system. Very huge amounts of data can be stored. Faster data processing, velocity, very fastly process all the data. Key aspects: open source software, framework, distributed, massive storage, faster processing. It's all the key aspects. Okay, open source in the sense what, it's available for everyone to use it, cheap. The framework of it, all the things it consists of, Hadoop, what it does, HDFS, Hive, etc., etc. Distributed, multiple nodes. If one crash, another is also always there. Massive storage, can store petabytes of data. Also transfers easily. Faster processing, all this huge amount of data can be processed easily by distributing the data among multiple nodes, and in parallel all the nodes will be working. Understood, right? Hadoop component, you have HDFS and MapReduce, major 2 components. But if you talk about ecosystem, it's nothing but comes under component itself. So you have Hive, Peak, Scoop, HBase, Flume, Oozie, Mahout. So these all are in one table related to Hadoop itself. So each has its individual work, which will be further discussed in module 4. Okay, Hadoop content, ecosystem, all of this. I won't be repeating about this because I have already explained in the previous video. We have high level conceptual layer in Hadoop. So it is basically a diagram. Let me just draw a part like that. So here you have one node. It is interacting with 3 other nodes. So this is the master node. These are the slave nodes. Okay. So this basically master node is nothing but it consists of 2 things: master HDFS and master MapReduce. So master HDFS, what it does, it partitions the data, in the sense what, distributes, divides the data into different chunks and assigns it to the slave, and also it keeps a track of the data. What is the master MapReduce does? It basically divides or distributes the conceptual task among the slaves. So each data is distributed into chunks, different parts of blocks of data. It is then given to the slave. They process it, then finish it. Use case of Hadoop is mainly for clickstreams. What is clickstream? Clickstream is nothing but whenever you are browsing or sometimes any website visiting, whatever you click with your mouse, that is one click, right? That is nothing but clickstream. with the help of this clickstream pattern, wherever you click what you have clicked, they help in marketizing, market all those uprising and all, which helps the market to develop much good product and understand the users, what does the user like, users experience, users interest, like that. Okay, so that's all about Hadoop. And actual HDFS we'll be discussing the next video, in which we'll be discussing how the Hadoop works, how the input is taken, output is taken, or something, how it is processed. So we'll see that in the next video. So for that, till now, I hope you have understood this concept. So kindly give a like and subscribe to the channel.